Hello, welcome to Fall 2016's Learning OpenFlow SDM for Research and Experimentation version 1.0's SwitchTester application. This project is for the School of Computing and Information Sciences at Florida International University. The two team members involved in this project include myself, Jaquel Lazar, as well as Stephen Lyons. And the product owner for this project was Vasilika Chergorova, our mentor Mohsen Tahiri, and our instructor Masoud Sajadi. So what is SwitchTester? So SwitchTester is an application that leverages the OpenFlow protocol and software-defined networking. So let's get into a little bit what OpenFlow is and software-defined networking is. So OpenFlow is a protocol. It's a communications protocol specifically that's used with OpenFlow switches. And these switches are network devices, just like your regular switches that you have in a data center, for example, or in maybe your own business. But these are basic network switches. They could be layer 3 switches or anything else like that. But specifically, they implement the OpenFlow protocol. And OpenFlow is an implementation of software-defined networking, which pretty much provides an abstraction over lower-level functionality. It allows network engineers to configure their network through software. So basically, the definition of our project is that we must be able to test OpenFlow switches and make sure that they conform to the OpenFlow specification. There are different versions of the protocol. There's 1.0, 1.1, all the way to 1.3, to our knowledge at least, as the publication date of this presentation. So we need to be able to test these switches, make sure that they fully conform to the specific protocol version of OpenFlow. And we also must define an application profile that specifies a compatibility list of test cases to which the switch must conform to. And these are kind of examples of output from two existing test frameworks called Ryu and OFTest. And basically they define test cases and they run the test against the switch and make sure that they pass validation. So here we have, for example, the test case name followed by the result, error, okay, and the execution time. So SwitchTester uses OFTest and Ryu, these two testing frameworks, to be able to accomplish this task. So the current system is that a network engineer would have to run one of these testing frameworks, and they'd kind of have to learn how to use them. And very verbose output is put to the terminal, and that's something that a network engineer doesn't want to see. Going back to these two images here, we can see, for example, on the left image, this is Ryu running. We have a lot of this verbose output, and sometimes network engineer most of the time a network engineer doesn't want to see this. They kind of want to just see what's going on, what's the error that occurred, and why did it occur. So that was a huge problem for testing frameworks like OFTest and Ryu. So we need to be able to output data in a very human-readable format. For example, JSON or CSV. It's basically a report that shows something similar, right? It has the test case name and then the result followed. Error, okay, failure, things of that nature. Then we have some configuration for application, which specify the configuration of the app, as well as configuration of the switch that we're testing, making sure that it passes validation, and application profile. We'll go into what an application profile is in a bit. This is basically how the application looks like to the network engineer, which is the end user for our software. So they want to check OpenFlow 1.0 switch compatibility. So what the SwitchTester application will do is load the configuration, load the target switch information, load the application profile, and then run either OFTest or Ryu, whichever is the testing framework to use. So this is kind of how the internal structure of our application looks like. So the network engineer communicates with the CLI of the SwitchTester application, and SwitchTester uses core tester, which is basically an abstraction over the testing framework. So remember how I said earlier that the network engineer had to either know how to use Ryu specifically or how to use OFTest specifically. Well, the great thing about our application is that it provides an abstraction over these testing frameworks, allowing for an additional testing framework to be added in the future if this is something that the end user wanted to do, or developer. So OFTest tester is the part of the application that uses OFTest for testing, and then Ryu tester uses Ryu for testing. And they both rely on the core tester for configuration, and they kind of implement some of the functions that are exposed to allow for this kind of dynamic utilization of different testers. So this is an example of the class diagram. Network engineer again communicates with the CLI, which is just an interface, communicates with the SwitchTester, which is the application. Then it dynamically figures out which testing framework to use based off of the OpenFlow protocol version. OFTest works with 1.0 and 1.1, and Ryu works with 1.3. So based off of those specifications, we'll figure out which ones to use. So user story 1 was to implement a sample topology in Mininet. So Mininet is a virtual machine that allows you to create virtual network topologies, and this is something that we needed because what we have is a network topology called AMLite. AMLite is a network that spans across North America as well as South America, specifically parts of Florida and Brazil, and maybe some other regions as well, but those are the two primary regions, and they are connected through fiber cables, and we need to be able to kind of simulate this environment in a virtual context, because this is basically where our application is going to be run. So we need to make sure that it works on actual virtual devices before we test it on physical devices. So we had to simulate this topology. So the physical topologies will be represented like this on Mininet. Then in OESS we had to provision a VLAN circuits across the entire network. And OESS is basically a controller. It exposes an interface for a network engineer to basically do things like this: provision network circuits, VLAN circuits specifically. So the acceptance criteria was to be able to demo the working environment, create an OpenFlow entry in the working environment, and the host had to be able to connect to Mininet with VLAN support. So the second user story was to create an SDN validation environment to test the switch. So this was using OFTest specifically. This is part 1. Basically, throughout the entire project, this was the idea to work on this SDN validation environment, which is our SwitchTester application. So as a user of AMLite, I need a way to validate switches automatically to ease the installation of switches into AMLite. So this is going to be a very common theme throughout the remainder of this project. So acceptance criteria: understand what is OFTest and run on Mininet. So this is a use case diagram basically describing how the network engineer will communicate with the application. So at this point, me and my teammate kind of our work was divided. So he would work on the Ryu part, and I would work on the OFTest part. So we didn't have a common application to work on. We kind of just worked on our two separate software, and then at a later time we would join our applications. So this is an example of running OFTest, and then some of the results here. Then this is the Ryu part. So this is part 1, user story number 3. And this is an example of running Ryu Manager, which is basically the Ryu testing framework. This is part 2, so generating the report. So this is some configuration that we initially had. This was in a kind of like an INI format that you would see on Windows, specifying, for example, the interfaces that you want to use, OpenFlow port numbers, the executable path for OFTest, and so on and so forth. And this was kind of an example of a report that we had. This was in JSON format. So you can see, for example, the test case name, the result, the number of errors that occurred, number of failures that occurred, and runtime. Later on, we kind of stripped the report of some of those extra things that we didn't really need. This is an example of running Ryu. So we passed some application profile, which specifies a compatibility list of test cases that the switch must pass. So here, this is a sunny example, and it passed. Part 3, this is us actually running our application on real devices and creating a report and defining the application profile. These are some of the functionalities here for core tester as well as Ryu tester, and you'll see something similar for OFTest tester as well. So this is an example of a sunny. This is an example of a sunny test case. So here we have the model sunny compatibility list. Just consists of this one test. Act output is the name of the test case, and it passed, as we can see here. Now for this one, we just specify doesn't exist. So doesn't exist is not an actual test case name. So of course the switch will fail on this example. So for this rainy example, the test switch actually failed, and this is the expected result and the actual result here. And you can kind of compare those to the sunny example. Okay, so now we're ready for a demo of our application. So this is running on Mininet, which is the virtual machine that we talked about earlier. So right now we'll go to the root of our application. So basically a network engineer will come up here and run our application. So it's a Python application. They can specify verbose, which outputs certain information depending on whether the flag is specified or not. Then we need to pass the target switch configuration. This is basically the name of the switch, as well as some other configuration specific to the testing framework. And then we'll pass the profile, which is the application profile. And all of these are JSON files. So we'll run the application, and here you can see that it loads the profile, it loads the configuration, and it starts running the tests. So this is OFTest, outputting the test case names that we talked about earlier, as well as the result, error, okay, so on and so forth. So this will run for about 2 to 5 minutes, depending on how many test cases that you have. But I go ahead and cancel that because that will take a while. And I'll just go ahead and show you what the output should look like. So after running the application, we should see something like this. So this is an example of the JSON report. So this is the test case name, as well as the result, error, and then the detail, which is the description of the error. And if the test case did pass, then the detail would be none, for example. Now let's open up the CSV file. This one is a little bit more simplified, so we don't have any error descriptions or anything like that. We just have the test case name and then the result. This makes things very easy for network engineers. It's very readable. There aren't any verbose messages or any code or any exceptions like stack traces being shown. It's just a very simplified view that could be imported into a database or into a spreadsheet, for example, and it's very human readable, and it's very usable by programs as well. So let's show the actual application profile so we can see how that looks like. So this is the name of the profile, the OpenFlow version that we're testing. So this is 1.0, so that's why it used OFTest. The compatibility list, which basically is the list of test cases that the switch must pass, and we didn't see that result because the application was still running and it would take a while to run, but it would say something like passed or failed depending on if any of these failed. And then I'll show the target switch configuration. It's the name of the switch, the description of the switch, OpenFlow version, and configuration specific to Ryu and specific to OFTest. So this may be something you may or may not need to touch depending on what your needs are. And that's basically it. Thank you for joining us in our introduction video for our SwitchTester application.